right, here we go. When we look at number 1, there's only one of these that we can use direct substitution for. Remember, direct substitution is when we can immediately plug in the value of the limit. Which one is the one? Which one? A, right? A is the one I can plug in for. Because the rest, if I plugged in for the value of the limit, it would make the denominator 0, which is problematic because it would be undefined. So the only one I can use direct substitution for is the first one. So in the top I would get 5 plus 0 because I can sub in for x, and then 0 plus 3, so 5 thirds is the, bless you, limit for part A. Part B, I can't plug in because, like I said, it's going to make my denominator 0. So I think through the strategies that I have. One of them is factoring, and I know at first glance it might not look like you can factor here because if you look at the numerator, there's not a lot going on, right? So it almost looks like, well, what can I factor? Well, not much, but you can pull out a 2, right? So I'm going to go ahead and pull out a 2, and I'll be left with x plus 5. What can I factor out of the denominator? We can take out an x, and what am I left with? X plus 5 again. So those cancel. Now I'm looking at just this piece. Can I plug in for x now? Yes. So at this point I can plug in. My limit is going to be 2 over negative 5. You can have the negatives down below, off to the side, up top, wherever you want it. There does need to be a negative. So this will be my final answer. Remember, as soon as you've enacted the limit, this whole limit bit can go away. So just like if you square root something, the square root doesn't live on forever. So once you've taken the limit by plugging it in, it's done. All right, part C. I actually started factoring this last hour, and they didn't love that. Do you see how it's kind of a nice little difference of 2 squares? Oh, I forgot to tell you that I changed it. Did you do it this way? You did it this way, because of course you did. Okay, make this a 6. And it's going to make this problem. So sorry.
Will that change my whole limit?
Yes, that should change it. It does make it so much easier. Okay, I'm so sorry. I'm going to avoid eye contact. I'm so sorry. Okay, let's pretend that didn't happen. Okay, so let's pretend that I remembered to tell you. So the limit as x approaches 0, I'm going to actually FOIL this out. So I get x squared plus 12x plus 36. Then I have a minus 36 all over x. Doesn't that work out much better, people? Sorry. Now that the problem's completely different, what happens to the 36s? They cancel. And if I divide the x into the remaining part, I get the limit as x approaches 0 of x plus 12. Can I plug in for x now? Yes. 0 plus 12? 12. Not, yeah, sorry, my bad. That's my fault. I will own the fact that I made your eye twitch. Okay, this one, I'm going to multiply by the conjugate. So I'm going to multiply top and bottom by 4 plus root x. So again, remember that if you have a root, sometimes it helps you to rationalize things, which means multiplying by the conjugate. The limit as x approaches 16 of, remember that you can just fold. You don't actually have to FOIL. The O and the I don't matter because they'll cancel out. Right? That's how we set it up. So truly, you just have to do the first and last. So 4 times 4, 16. Positive root x times negative root x is negative root x squared. Well, the root and the x squared cancel, so it's just minus x. In the denominator, I have this 4 plus root x. Also, do you see how this parenthesis almost matches this one? Could I take out an x, and yes, it's oddly sandwiched in the middle, but we're going to make our peace with that. And then I would be left with 16 minus x. Are we okay with that step? Okay, so now what can cancel? The 16 minus x's in top and bottom. The limit as x approaches 16 of 1, so everything's gone in the top, over x times 4 plus root x. Can I plug in the 16 now? Yes, it will make my denominator 0. 1 over 16 times 4 plus 4. The square root of 16 gives me that second 4. So I have 1 over 16 times 8, and I think it was 128. Yeah? Let me make it look better. Is that what we got? Okay. 128. Okay, so besides the debacle with part C, which I take full responsibility for, how were the rest? Were those okay? Good. Okay. On the test tomorrow, these are not going to be true false. The way they're going to be presented is that you're going to be asked for the limit and then you're going to give the value. Personally, I feel like I might screw it up if I was given a true false question, because sometimes you read it and you're like, oh yeah, that was good, that's true. And I feel like I don't know, I feel like I put true more than I should for problems like that. So I did change it so it's actually finding. Here we go. Remember, these were the ones where I was drawing little stick figures and I was saying I was walking toward a certain spot. If it helps you to think about that in that way, go for it. Okay, so I'm approaching 0 from negative land. Negative land is over here, right? That's where my negative numbers live. And I'm approaching 0. This is 0 right along the y-axis. As I approach 0, what value of y am I headed toward? -2. So is this true? Yes. Yes. True. This one, I'm headed toward 0, but this time from positive land. As I head toward 0, am I heading toward a y value of 5? Yes. So true. Is the overall limit 0? False. What is it? Yeah, this would be a does not exist. Or last hour just shouted out Lindsay Lohan. So, which I mean, I knew what they meant. So, false, it doesn't exist because each side is going to a different spot. So overall, it's not going to the same location. Okay, look at this person again. We're headed toward 1, but from positive land. So here's 1 from positive land. What am I headed to in terms of y? 5. So true? Yep. Perfect. How'd we do on those? Okay? Again, I just get a little nervous about true, false, and second guessing yourself, so tomorrow you'll just be finding the limit as opposed to what we were just doing. Alright, next one. I feel like this is one of the bigger point questions on the test. Because, well, it is. And so basically this one, listen, this one is asking you to graph, so you're going to get points for graphing. And then on top of all that, it's asking you to find the limit. Here we go. So, we're being asked to graph. This is a piecewise function. It's given to us in 2 pieces. Remember that even though this says x is less than 1, I still start at 1. Because otherwise, it brings up the debate of, well, what do we say is less than 1? Would it be 0? Would it be 0.5? Would it be 0.9? 0.99? So instead of playing that game, we're going to just start at 1 and put an open circle there. If I plug in 1, I get out 4. Now I'm going to go smaller. If I plug in 0, I get out 3. If I plug in -1, I get out 2. And you can even remind yourself and say, like, hey, self, make sure that you put an open circle here. For the other part, this truly wants me to start at 1 and then get bigger than 1. So I'm going to go 1, 2, 3. If I plug in 1, 1/2 minus 1, -1/2. 2, 2 over 2 is 1, 1 minus 1 is 0. 3 over 2 is 1 1/2, minus 1 is positive 1/2. So let's go ahead and graph. So all the other points can be closed, the only open one is at 1, 4. So let me start there so I don't forget. Open circle, 1, 4. Another point at 0, 3. Another point at negative 1, 2. And I'm headed this way. Close circle at over 1, down at negative 0.5. 2, 0, 3, and positive 0.5. I don't think my spacing is great there, but we're just going to roll with it. Okay, so you're going to get points for the graph, so make sure that you graph and you show me what those look like. Does the limit exist at 1? No. I could find a left hand and a right hand limit, but I can't find the overall limit because they don't head to the same thing. So does the limit exist? No. What about at 4? Yeah. So we plug in 4. 4 fits into this round. 4 divided by 2 is 2. 2 minus 1 is 1. So the answer is yes, it exists. What is it? 1. You can't see that. Now you can. Good. Questions on that one? Okay, the last 3 are all just a smidge different from each other. Here's the next one. So this one you're given the entire ordered pair, and it's asking you to find the equation. Alright, so this one is asking for the equation of the tangent line. So yes, I'm going to find the slope the way that we've been doing it using limits, but on top of finding the slope, I also need to plug it into point slope form. Remember, point slope form is y minus y1 equals m times x minus x1. If you would like to transition it from there into point slope form, slope intercept form, you can, which is y equals mx plus b. But you don't have to. The limit as h approaches 0 of, first of all, what is this? It's an 8, but also it is a. And this is f of a. Sorry, you guys were looking at that like it was a trick question. What is that? It's an 8. Okay. A and f of a. So we've got f of a plus h minus f of a all over h. So remember, this is the basic formula. Okay, so that's your limit formula to go through and find slope. So again, we're finding slope of 2 points as they approach each other. Alright, so now I'm going to go ahead and plug in. I need to plug in my 8 plus h. So I get the square root of 2 times h plus 8. So that'll be 2h plus 16. And then I have my minus 4 at the end, and it's all over h. So I took this, and I plugged it in here, and I doubled it. So this became 16, this became 2h. And you know I can't live my life without the variable being in front, so I moved it out front. What strategy am I going to want to use here? Rationalize the numerator. So I'm going to multiply top and bottom by the square root of 2h plus 16 plus 4. Remember that it doesn't help us to multiply out the denominator. So I'm going to leave the denominator as it stands. Okay, so the denominator stays put. The numerator, remember, we can just fold. We don't need to do the O and the I because those will cancel each other out. If I multiply these two together, the fact that it's being squared and square rooted, it cancels each other out. So I'm left with 2h plus 16. And then I can do the last. What do I get there? Negative 4 times positive 4. Negative 16. Make sure your phones and other stuff are away and you're with me, please. What happens to my 16? Boom, gone. Then I can cancel this h and this h with each other. So I've got the limit as h approaches 0. All I have left in my numerator is a 2. In the denominator, I have 2h plus 16 plus 4. Can I plug in my 0 now? Yes. So let's plug it in. That'll zero out this first term. So I get 2 over, what do we know the square root of 16 is? 4. So it's 4 plus 4, which is 8. And what does that reduce to? 1/4. So there's my slope. And then I'm going to plug that into my formula along with my points. And instead of thinking of it as a and f of a, I'm going to think of it as x1 and y1 this time. So y minus y1 equals m times x minus x1. And this is the final answer. If you want to distribute and then move over the 4 and put it into slope-intercept form, you can. You do not have to. Are you ready? We have 2 more. Okay, I think I'm going to show you both at once and then have you try both of these. I'm going to shrink it down just a little bit so you can see both at the same time. Cool. So last 2, again, you'll notice just some minute differences between these last 3 problems. So be careful. Make sure you're reading the directions carefully and looking at what you're given carefully as well. All right. For this one, we're asked to find the derivative at 4. Remember, that means 4 is my a value. I don't have f of a like I did for the last one, so I need to calculate it. How can I find f of a? Plug it in. So 16 minus 12, which gives me 4. So they're both 4s. Here we go. The limit as h approaches 0 of f of a plus h. So f of 4 plus h minus f of a all over h. So now I'm here. So I did basically the same thing I did last time to start with, but I had to find my f of a first. Limit as h approaches 0. Again, I can't directly substitute yet because it would make my denominator 0. So what I'm going to do is I'm going to take my 4 plus h and I'm going to plug it into the equation like a composition function. So I'm going to have h plus 4 squared minus 3, bless you, times h plus 4 minus 4. Well, that looks awful. Pretend that looks better than how it actually looks. And also pretend it's correct. So many things we need to pretend here. This should be it. Okay, so I plugged in my h plus 4 here, and then here, and then there's the minus 4 that was living at the end, and the h still in the bottom. The limit as h approaches 0 of, I'm going to FOIL this out. H times h would give me h squared. Remember, this is really saying take h plus 4 and multiply it by itself. So here's my h squared. 4h and 4h gives me 8 h's. And then 4 times 4 gives me 16. Minus 3h minus 12, careful with your signs, minus 4. All over h. Ooh my, a lot of things. The limit as h approaches 0. We know some stuff should cancel, and if it doesn't, then maybe we did some math wrong and we gotta go back and check. What can cancel? The 16 with what? Yeah, so 16 13 minus 12 minus 4 gives me 0. Now, those are the only things that can cancel, but can I combine my h's? Yep, so I get h squared plus 5h all over h. Can I divide the h in? Yep. So I get the limit as h approaches 0 of h plus 5, because I'm dividing an h away from each. Or you could think of factoring it out and then canceling. Can I plug in my 0 now? What do I get? 5. Your derivative is the slope. So boom, I'm done. I don't need to put it into the point slope or slope intercept form or anything else. The last one is a tad bit different because it's looking for just the basic formula. So I'm going to plug in, and I'm not going to plug in anything for a or f of a. The limit as h approaches 0. I'm going to first plug in a plus h. So I'm plugging in a plus h first. How do we feel about how I plugged in a plus h? We good with that? Minus f of a. What do I get when I just plug in a? A plus 7. And then all over h. Can I plug in my 0? Bummer. Okay. I'm going to go ahead and multiply by the conjugate, because again, if I have roots, that's what I need to do. So I'm going to multiply by a plus h plus 7 plus a plus 7. Did I multiply it to the top? I also have to multiply it to the bottom. This is a plus, by the way. It doesn't look like one, and that's bothering me. Also, the parentheses kind of halfway through it. So many things bothering me about that, but we're just going to push forward. Alright, in the denominator, we know at this point that it doesn't help us to multiply it out or to try to factor or do anything extra. We're just going to leave it as it stands. In the top, remember that the middle two terms should cancel out. So truly, I'm multiplying the first and the last only. The fact that these two things are going to be squared counteracts with the square root. So I get a plus h plus 7. Again, the square root counteracting the square. A negative times a positive is a negative, and it's going to be the whole bit that follows it that we are going to have negative. The square and the square root counteract, so a plus 7. So this is going to be a negative a minus 7. So what cancels? The a's, the 7's, and I just have an h, which can cancel with the 1 in the denominator. Limit as h approaches 0. We have a 1 in the top to hold the fraction in place. In the denominator, a plus h plus 7 plus square root a plus 7. Can I plug in the 0 now? Yes. So I have 1 over a plus 0 plus 7. Well, that's just a plus 7. Do you see how I have two of the same roots now? So I'm just going to simplify one last bit here and say it's 2 a plus 7. Boom, done. Okay, so I'm going to post the video, and then I'm also going to post the pictures of the assignment. Questions before the test?